Hello friends, I'm Swapna Shetty. In this video, we are going to know what is an exception and what happens in the background when an exception occurs. That is, what is runtime stack mechanism and what is default exception handling and the hierarchy of the exception, and few blocks like try catch finally and two keywords like through and throughs. So what is basically an exception? An unwanted or unexpected event that disturb normal flow of the program is called an exception. For example, when you're sleeping and suddenly when you wake up, it is a sleeping exception. And when you're going somewhere on a vehicle and your vehicle tire got punctured, that's a tire punctured exception. And if you want me to speak in programming terms, when you're trying to open a file which is not existing, that's a file not found exception. So as a good programming practice, it is always necessary to handle an exception. Handling an exception doesn't mean repairing an exception. We are providing an alternative way to continue the rest of the program normally. The main objective of exception handling is the graceful termination of the program. Next is runtime stack mechanism. So for every thread, if I say thread means a separate process of execution of a program. So for every thread, JVM will create a runtime stack. So all the method calls performed will be stored in the stack. Each entry in the stack is known as a stack frame or an activation record. So once the method terminates normally, then the corresponding entry from the stack will be popped out. After completing all the method calls, just before terminating the thread, JVM destroys the corresponding stack. So let's see an example of this. I create a project called exception samples, in which I create a class called test with the main method and a package com.educators. So here in my main method, I'm calling a method, say, do stuff. So create a method do stuff, make it as a public. In this method, I'm calling another method, say, do more stuff. So create a method do more stuff. In which I'm just printing hello. So let's see what happens in the background. When I execute this, I get an output, say it's in hello. So what exactly happens in the background? That's where we see here. So first of all, my main method is being called. So the entry in the stack would be my main. So for that, I just create an entry in the stack in which it contains main method. And main method is calling another method, say do stuff. So I just say that do stuff will be entered into the stack. An entry is made into the stack. Do stuff is calling do more stuff. So another entry will be made in the stack. So it is do more stuff. So when JVM executes a do more stuff, it just prints, and after completion of the method call, the corresponding entry from the stack will be removed. And then the control will go back to the method from where it has been called, that is do stuff. So do stuff is the method which completes its execution and the corresponding entry from the stack will be removed. And then correspondingly, the main also gets removed. So just before destroying the stack, if there is an exception in the program, Then the JVM will hand over that exception handling feature to the default exception handler. If there is no exception, the program will be terminated normally, and then the stack will be removed. So what is default exception handling mechanism? So default exception handling is nothing but it's a component. It's a default exception handler is a component of JVM which just prints the exception information in the following format. That is, it is the name of the exception followed by the description of the exception and then the location of the exception. So whenever an exception occurs, the method in which it is raised is responsible for the preparation of the exception object. That is, in that object, how does it prepare is it includes some information like name of the exception like java.lang.arithmetic exception, description is divide by 0, and the location where exception occurs, that is nothing but the stack trace. So after creation of exception object, that method hands over its to the JVM. Now JVM will check for the required exception handling in that method. If it is not available, then JVM terminates the method abnormally and removes the corresponding entry from the stack. That is, if suppose do more stuff is having an exception, that is I'm trying to print a number which is divided by 0. A number can't be divided by 0, so it's an arithmetic exception. So first here JVM will check if there is any exception handling done in this method, that is do more stuff. If it is not available, then JVM terminates this method abnormally and removes the corresponding entry from the stack. Then JVM searches for the exception handling in the caller method, that is in the do stuff method. If it doesn't contain any exception handling code, then it terminates that method also and removes the corresponding entry from the stack. So this process will go on till main. If main also doesn't contain any exception handling code, then JVM terminates the code abnormally and removes the corresponding entry from the stack. So just before terminating the program abnormally, JVM hands over the responsibility of exception handling to the default exception handler, which is a component of JVM. So it just prints the information in the following format. So let's see what is that format. You can see it is printing an exception name first, that is arithmetic exception, and the description of the exception, that is divide by 0, and this is nothing but the location of the exception, that is the stack trace. So this is how the JVM gives the responsibility of exception handling to the default exception handler. Next is exception hierarchy. So the superclass of all classes in Java is object, and throwable is a subclass of object in which we have error and exception. So under exception we have runtime exception and IO exception. Under runtime we got illegal argument exception, number format, arithmetic, index out of bounds exception, array index out of bounds exception, and so on. Similarly, under exception we have also got IO exception, under which we got file not found exception and socket exception. So error, out of memory error, stack overflow, linkage errors. So if I say what is the difference between error and exception? Error is something which are not caused by our program, and these are due to some lack of system resources like memory, out of memory error and stack overflow and so on, which are non-recoverable. Whereas exception mostly caused by our program, and these are recoverable. So throwable is the superclass of all the exceptions. So under runtime exception, the classes under runtime exception and under error are all unchecked exceptions, whereas all the remaining other classes comes under checked exceptions. So what is checked and unchecked is? Checked exceptions are those exceptions which are checked by the compiler for smooth execution of the program at runtime, which is, for example, interrupted exception. Unchecked exceptions are those exceptions which are checked by the JVM and at runtime, like arithmetic exception. So if I say an exception, it is always at runtime. It is not at any compile time. So try catch finally. So try block, in try block we place the risky code, and in catch block we place the corresponding handling code. Let's see an example of it. For example, now we have got an exception here. So how do we handle this exception is we put the risky code in try block, something like this. And how do we handle this exception is using catch block. So the exception name is arithmetic exception. So I simply say arithmetic exception name AE, and I would handle it by simply saying instead of 10 by 2 I just print 10 by 0, I just print 10 by 2. So let's try running the program. Run as Java application. You can see the output printed as 5. So whenever the control comes to print 10 by 0, so since it is in try block, it will search for the corresponding catch block. So this is arithmetic exception, so it will search for a catch block of arithmetic exception. So whenever it finds, it executes the corresponding statements within the catch block. So this is how we handle an exception. We can also write multiple catch blocks. For example, exception E. Under this, I may write something like so for a try, if I get multiple exceptions within the try block, I can handle those exceptions using multiple catch blocks. But the order of exceptions should be from subclass to the superclass. So if I write something like this, first is exception and then the superclass and then the subclass, this will not execute. I would get an error saying unreachable catch block for arithmetic exceptions. It is already handled by the catch block for exception because exception is the superclass of all exceptions. So whenever I get an exception, that exception would be handled by the first catch block. So the order should be from subclass to the superclass. Similarly, finally is a keyword, is a block where we can handle whether an exception is raised or not, this finally blocks gets executed. So generally we write some cleaning up of resources code in a finally block. When we are trying to open a file and after processing the file, we need to close those files for any security reasons. So for such closing code and all should be written in finally block. And whether an exception is raised or not raised, finally block gets executed. For example, in finally, I would just print it as final block. So after try block, when try block is getting an exception, the corresponding catch block is executed and finally block also got executed. So cleaning up of resources code, such code is written in finally block. If cleaning up of resources code is written in try block, there is no guarantee that all the statements in the try block gets executed. So that is the reason we cannot write cleaning up of resources code in try block. Similarly, catch block. It is not, if an exception is not raised, catch blocks are not executed. So that is the reason cleaning up of resources code is written in finally block and not in try and catch blocks. Next is throw keyword. It is used to hand over the explicitly created object to the JVM. It is normally used for customized exceptions. Customized is user defined exceptions. So let's see how do we throw explicitly an exception object using throw keyword. So for that I would just write another class, so throw demo, with a main in a package com.educators. After creating a throw demo, now throw is a keyword used to throw an exception object explicitly. So I just simply say throw new arithmetic exception. So it is simply an exception is throw. Now if I write any statement after throw, like hello, we would get a compile time error saying unreachable code. So after using throw keyword, we are explicitly, so we should not write any statement after using throw keyword. That means if I say throw, it is we are throwing an exception object to the JVM. So the control cannot come back to the next statement. So writing statements after throw is not required. So we should remove this. And moreover, we cannot use throw to a keyword to throw any object. For example, if I say throw new throw demo, that is I'm throwing new throw is an object of throw demo. New throw demo is an object of throw demo. But when I use throw for throwing such objects, we cannot throw. My object should be of an exception object. That is, my class should be a subclass of an exception. Then only I can use throw keyword. So even though my throw demo class, that is user defined class, is a subclass of exception, still we can see the compile time error saying the exception has to be handled either using throws or try catch, because my subclass should be a subclass of runtime exception and not an exception. That is, my user defined class should be of unchecked exception. So it should extend runtime exception. Then you cannot see a compile time error. So here throw is a keyword used to hand over the explicitly created exception object to the JVM, and it is normally used for throwing customized exceptions, that is user defined exceptions. And we have seen unreachable statement. If we write any statement after throw statement, that code is not reachable. And moreover, we use throw keyword only for throwable objects. And throws is a keyword used to delegate the responsibility of exception handling to the caller. So let's see this using, for example, the same test class I'm taking, and here in do more stuff, I would just say thread dot sleep of some 1000. I'm just making the thread to sleep for 1000 milliseconds. So you can see a compile time error saying the exception is not handled, that is interrupted exception. So if I don't want to handle this exception, I can simply throw it out of a method using throws declaration. So I simply add throws declaration. So it would add something like this, throws interrupted exception. Then the compile time error got vanished. But throws is a keyword that it delegates the responsibility of exception handling to the caller. So do more stuff is being called by do stuff method. So if do more stuff is throwing an exception, do stuff should also throw the exception. That is what is the compile time error here. that is unhandled exception type interrupted exception. So simply add throws declaration. So you can see compile time error is not. So similarly, even main method should also throw this interrupted exception. So add this throws declaration. So without handling the code using try catch, I'm just using throws keyword to throw out the exception from the method. So let's run and check. Run as Java application. So the application is running. So we use throws for only throwing checked exception. Interrupted exception is a checked exception. There is no impact on throws keyword when we are trying to throw an unchecked exception. So mainly we use throws keyword to throw checked exceptions. That's all with the session. Thank you.